Hello, everyone. Welcome back to the class of, no, it is fifth, right? Class of computer networks and artificial intelligence. So we're gonna talk about some email security protocols. So lots of email security protocols also use public key infrastructure, but the reason why I put many email security protocols is there are lots of email security protocols, right? So each of them has different purposes. So my ambitious plan is to walk you through all major internet email security protocols and try to make you understand a very general surface of them, okay? After that, if you are more interested in specific protocols, I think you can study by yourself, but after understanding how it works in general, you will be better. You'll be able to understand much better in depth a specific email security protocols that you're interested in. So let me start. So there are actually two perspectives when we want to cover email security protocols. The first one is the sender's perspective. So as you can guess very easily, the one of the major problems of email protocol is sender authentication, because I'm sure that you must have received lots of spam emails impersonating a legitimate entity such as Amazon or Google, such as, hey, I am Google administrator. It looks like you forgot your password, so we are sending your email, so please check your account number, but yada, 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 right? So there are lots of extensions on top of current email plain protocol, which is SMTP, to provide sender authentication information or encryption or the other protocols just to support the mobile clients. The other perspective is receiver's perspective. So for example, you'd like to send the email to one entity, right? Then the problem is, how can you be so sure that you're communicating with the entity that you intended to, right? So for example, you went to google.com's mail server and you like to push your email, send your email to google.com server, right? Then the challenge here is, how can you make sure you connected to the right server, Google server? And also, if you like to encrypt the email to provide confidentiality, what kinds of keys you're going to use, right? So one large perspective is senders versus receivers perspective, okay? The other one is in terms of security goals, okay? So for example, you might be only interested in encrypting your email content, right? Or you might be interested in checking the sender information, whether let's say you don't care about any confidentiality at all, it is fine, even email is not encrypted, but you might be only interested in checking the sender, if the sender is a legitimate entity, right? For example, you receive an email from whitehouse.gov, right? Then you want to make sure that you receive the email from actual whitehouse.gov, right? So that is about authenticity, okay? Sometimes you might be only interested in integrity, right? Let's say you don't care about the confidentiality, but you want to check if this email has never been forged, right? Has never been modified at all. If this email is the same email actually sent from the sender, okay? So there are in large two different areas. The first one is, whether you're going to study a specific protocols by focusing on the sender or focusing on the receiver. And the other one is whether you focus on email security protocols by considering different security goals, whether this protocol is designed to support integrity or whether this protocol is designed to support authenticity or confidentiality, all right? The reason why I would like to make this criteria set up first is because, again, there are a bunch of email security protocols. So one reason you might be wondering, hey, professor, why there are too many, security internet email protocols? Because it is because one main reason is to support backward compatibility. Okay, so email was designed about nearly 30, 40 years ago. At the time, the functionality is the top priority. So as time goes by, we use the primitive version of email security protocols very well. But as time goes by, we want to add a security layer on top of the existing email protocol, right? Because to support backward compatibility. All right. So let's say, hey, we need a sender authentication mechanism. So we add another layer to existing plain SMTP protocol to support sender authentication. But as time goes by, someone said, hey, we need an encryption methodology. So, okay, we add another, extension on top of the existing SMTP protocol in this way, right? But as you can imagine, of course, supporting backward compatibility is nice, right? Because it does not break any other existing protocol. But on the other hand, the problem is about the deployment, right? Because someone says, hey, it is already working very well. Why do I need to deploy? Why do I need to install this? Why do I need to support this external additional security protocols, right? So you will learn that some email security protocols is really rarely deployed, right? So, all right, let me start. So let's first understand how sender mail transfer protocol, simple mail transfer protocol, works from 10,000 feet point of view. Okay, so it is SMTP is the application layer protocol. You first use the TCP to make a connection, and after creating a TCP connection, lots of commands and responses are exchanged to actually deliver the message. Okay, so this email structure is very similar to the offline word mail structure, right? So first is envelope. Okay. The envelope contains, hey, this email is from this one, and the recipient to address is like this, right? You open up the email, and the email content, the from address might be different from the one specified in the envelope. For example, someone sends your email to your apartment address, right? And without specifying your name, such as, hey, this email is to deliver a specific apartment in Seoul. And it may say, hey, this email to address, right? This email has to be delivered to a certain apartment, building number, and the room office number, right? And as you open it, right, in the email content, then the recipient address may indicate your name, right? Or your household, name, or your friends, or I'm sorry, your sibling or your mother's name, your parents' name, right? So what I'm saying is the recipient to address and the mail from address specified on the mail envelope, right, can be different from in the email content, right? So if you're confused about this concept, again, please think about the real world situation. So it is really similar to the offline word email system. Okay. So as you can tell, there's a sender information. Hey, I'd like to connect to your server. And when you connect it, the server says, hey, my name is example.com. And client says, hey, my name is mydomainname.com. And this is my from address, okay? And the recipient too is example.com, right? And after that, the data command follows to specify the email content, okay? So that the email content can contain the subject, right? The title, and the from address, and the to address, okay? And the content, okay? So this is typically how it works. So if you want to test it by yourself, you can create a EC2 machine, and you can connect the one mail server using with the port number 25. And once the connection is established, then you can use this command hello in your domain name mail from and specify this command to actually deliver the email. But of course, when you try to, when you actually try to do it, there will be some challenges. For example, in case of some, popular hosting providers such as EC2 machine, it will not allow you to create a TCP connection with the outbound port number with 25, right? Because they're concerned about spam. So you have to ask your permission to open a port number with the 25, but let's assume that you can, just do it, all right? So now, of course, this is the very plain, basics, basic version of SMTP. Then the challenge is there was one security attack. I forgot the name. I'll add it on the note. So in the case, there is no authentication mechanism at all. So the receiver has no way to check if the sender is actually mydomain.com. Okay, so at the early stages, there are lots of spamming attacks that by modifying this field with the domain name that does not belong to the actual sender. All right. So to solve this limitation, Sender Policy Framework (SPF) policy protocol was introduced. So this allows the receiving mail server to check whether the incoming IP address, again, email protocol is an application level protocol. So which means you have to make a TCP connections to establish a kind of channel, right? So the receiver wants to check if this incoming IP address, right, the TCP connection, is actually authorized to use the sender domain name in the header. Okay, so the SPF just simply checks whether this IP address is allowed to use this domain name, right? Think about another potential scenario, such as I'm connected to any domain name, right, to send the email, and let's say, hey, my domain is google.com, right? Of course, my machine is not only Google managed by, not managed by google.com. So my IP address will be different from the actual machines of google.com, right? So this extension, SPF, allows the receiver to compare the IP address, owner of that IP address, and the domain name. So let's check that out. So let's say the sender SMTP server is 128, and the mail from is TJ, the Virginia Tech Edu. And receiver server, mail server, can send a DNS record request to TXT record for Virginia Tech Edu, right? Because the domain name was Edu. Then the sender has to, all right? The sender's Virginia Tech Edu's name server has to publish a DNS record, TXT record, saying, hey, the IP address range that we're allowed to use this VT.edu domain name is like this, okay? So in this example, the IP address is a prefix that includes this IP address. So the receiver, after retrieving this TXT record, and it tries to match if this IP address is a part of this, a TXT record, because it is, so that the receiver can trust this sender's check the authentication. Okay, so because you might be wondering, there is a include here because let's say Virginia Tech Mail Server uses other hosting providers such as Outlook, Microsoft, or Google. In that case, the Virginia Tech uses the third-party hosting providers, email hosting providers, to send and receive emails, which means they are authorized to send the email on behalf of original Virginia Tech Edu server. Okay, so if the receiver receives the email from VT.edu from actually Outlook, Microsoft hosting servers, then receiver wants to check if the IP address, right, is actually allowed to use VT.edu. in that case, the receiver will check out the vt.edu's the TXT record. And as you can tell, this TXT record includes Outlook as well as Google, right? Which means the sender has allowed Microsoft and Google to send the email on behalf of them. Okay. So as you can tell, this include actually does not specify the IP address. So what the receiver needs to do is they need to send additional TXT record request to look up this domain name. Okay. Then you will find out the actual domain, the IP address of this TXT record. So let me show you one example. Okay. So let's say, let's say I am receiving a SMTP solver. So I got the email from tj@virginiatech.edu, right? In the case, I need to look up the TXT record of vt.edu. Then as you can tell, oops, sorry. Okay. All right, so here, it specifies the IP address range, right? And also IPv6 address, and it includes SPF protection outlook. So let me look it up, this TXT record again, right? And it says this is the IP address range, which means this IP address, the list of IP addresses here is allowed to send the email on behalf of Outlook.com. Okay, so in a bigger picture, if Virginia Tech Edu's VT is outsourcing its email infrastructure to Outlook, then the receiver email server will check out the TXT record of Virginia Tech Edu, which includes SPF protection Outlook.com, and it will send another request for this domain name for TXT record, which includes this IP address range. So if the receiver SMTP server finds that the incoming IP address falls in this range, then it will believe that this incoming mail server is authorized. Okay. So let me keep going. So this example is a one very tiny, the simple example. But TXT records for SPF can include many different mechanisms. So for example, it can include V, which describes the version, and IPv4 range or IPv6 range or MX record. Sometimes it points out another type of DNS record. So if the MX record of the sender domain name matches with the incoming IP address, so then it is okay. So basically, if the MX record is there, then it tries to look up the domain name of the MX record, and the IP address is matched with this, the sender IP address, then it's fine. Okay. And this include is for refer. Okay, so as I showed you earlier, and there is a tilde all, which I'm going to explain later. So there are additional, other than the mechanism, there is a qualifier. Which is a criteria whether to receive or reject the email. For example, tilde is a self-fill. For example, if this IP address range falls into Outlook or Google and VT, it is accepted. But tilde all means if it is other than IP address range does not fall into this three includes, it is self-fill, right? Which means it is totally up to receiver whether to accept or reject the email. But if it is the minus, it is hard fill. So the solver says, the sender SMTP solver basically tells the receiver solver that, hey, if this incoming IP address does not fall into this range, you have to reject all the emails, right? So as you can imagine, this tilde is self-fill. So as we learned from the HTTPS class, if it is self-fill, then actually there is no much value on security protocol. So for the best recommendation is to always include minus all, not tilde all. Neutral is like the no policy, which means, oh, all right, your receiver, you have to pretend as if there were no policy at all. Okay. Okay. Why is my video is not working? All right, there was a technical glitch. I apologize. So let me just continue. The plus is the default, so it can be omitted. Again, neutral is like it can be interpreted like no policy. So usually whenever you see a TXT records for SPF, it is usually just tilde or minus. Okay. So as we previously covered from the last example, there can be a nest, can be a lasso includes. So for example, if you like to look up this SPF records, then you'll find that there's another SPF records pointed out, another SPF records, another SPF, and another IP addresses, right? So which means if you want to look up the actual IP address for the IP address range, you have to send a series of multiple DNS requests, okay? Which can be a kind of problematic. So for example, let's say you'd like to look up, let me show you an example. This SPF records, right? Then you will tell that, oh, there is another SPF records here. So if the incoming IP address falls into this range, it is good, right? But if it is not, it has to expand this domain name again, right? To make sure if the incoming IP address falls into this range, right? Again, if it is not here, you have to send another TXT record request, right? And finally, it contains all the IP address. So what I just did was I sent at least 44 DNS requests just to find out if the source IP address is authorized to send a email on behalf of this domain name, which means if a domain name is misconfigured, then the recipient SMTP server has to send many DNS requests to check if the incoming IP address is authorized or not. Because of the security issue, RFC actually recommends that the sender, the receiver has to limit the number of the total DNS lookup for SPF records by 10. All right. But this original specification RFC documents were originally documented about more than 10, 15 years ago, where that environment, where that web, where the internet looked totally different from where we are at right now. All right. In this days, there are lots of email hosting providers using other infrastructures. They rely on other infrastructures. So which means there can be a lot of nested TXT SPF records can exist, right? Because of that, some says this 10 lookup limit is not the realistic. So some use a 20 or 30 for their maximum lookup limit. Yeah. Another security protocol is DKIM, okay, domain keys identify email. So this is just to provide the integrity of the message. So the idea is very simple. The email comes with the signature. Then you have to check if the signature is correct or not. Then you need the public key. So it is very similar to DNS, right? The email content is now signed. Each email carries a signature. To verify the signature, what do you need? You need a public key. So in the email signature, you can find out the location of the keys, public keys that you can verify the signature, right? So this is just a quick example of the signature on the email header. So this key is the task the KIM, and the domain name is a hostcrp.com. So in that case, you can combine these two values together to get the actual key names of public key that sign this email. So let me show you one example, another example here. So this is my personal email account, and I just received an email from Let's Encrypt ACA. So you click this more button, and if you click this show original, then it shows you all the email content as well as email header information. So as you can tell, there are lots of email security protocols like ARC, which I will not cover. It's fairly new. And if you scroll bottom, and you will see that there is a domain name here, DKIM signature, right? So there is a signature over here, and to verify the signature, you have to get the public key. So the selector is mandrill, and the domain name is a Let's Encrypt org. So to get the public key information, what you can do is combine this two information together. Domain key is the and like this. Then you can get the public key, right? So you got the public key and you got the signature here, so the receiver can verify the signature, right? I just showed you a demo. So security properties that the DKIM provides is only integrity, right? And also non-repudiation. Non-repudiation concept is really interesting. So for example, non-repudiation, you can't deny that you have done, okay? You can't deny what you have done. For example, you sent the email and it carries a signature, and at the time that the receiver verified the signature, if the signature is valid, it means they were able to get the correct public key from your server, right? And it means if the signature is correct using your public key, that means you are the only person that have that private key as well, right? So if this information is correct, public key is correct, signature is correct, it means you actually sent the email to that person on that time, okay? So DKIM was actually used for Hillary Clinton email links, right? So Hillary was involved in one day accident that they're managing her personal email account, and of course she tried to deny that, hey, this email was not from my blah blah blah. It is. So because that email carried a signature, which can be verified using the DKIM at the time, which is with the timestamp. So if you're interested you can go to WikiLeaks and email, HillaryClinton.com, and it says all these signatures were valid at the time, which means this email actually sent from Hillary Clinton. Yeah. All right, DKIM also carries a lot of different tags and information, such as version number and signature algorithm. So it is very similar to DNS. Only differences is not only subtle differences is it carries a lot of selector. It can carry the selector information. So which means that a sender may have different keys depending on the sender. Okay, so for example, let's say this domain name hotcrp.com manages 5 different accounts, and each of different accounts can use different keys to sign to generate a signature. In that case, the email server can allocate different keys with the different selector, right? So that the receiver can choose a right selector to retrieve the public key information, right? So what I did was, to get the public key, I combine this S and the D, right, selector and the domain name together to get the public key. Okay. The third one is DMARC. DMARC is a domain name based message authentication, reporting, and confirmation. So it is more like a policy, so that it tells to the receiver that, hey, if you fail in validation of SPF or DKIM, this is the recommendation. This is the guideline that I want you to do, okay? So for example, hey, this is the DMARC, and I'm gonna talk about the root attack later. And the P means this is a desired action. Okay? If it is not, then it is, you can you should just deliver the message, and you pretend it as if there were no any demarkment policy at all. Q means if any validation fails, right? If you try to validate SPF and the DKIM, if either one fails, you should put that email into spam folder. If it is rejected, if the policy here is reject, it tells to the receiver that you have to reject the email, right? So there can be a multiple policy, based on the sender. So, and the roulette tag. The roulette tag allows your receiver to send a report for the emails coming from a domain name, okay? So for example, if VT sends many emails to a receiver that support this DMARC reporting, then what does the receiver do is, on a daily basis, it counts all the emails from Virginia Tech that it used, and also some useful statistics. For example, hey, I received 100 emails from VT.edu domain name, but 9% of them actually fail in validation, which means 9% of them tried to impersonate Virginia Tech.edu. So it collects, it prepares all these kind of reports and the statistics and generate a report and send this report to the email specify these addresses. Okay, so this roulette tag can contain many email addresses. In that case, of course, it is the receiver policy, but depending on receiver's policy, it may choose every single mail addresses specify the roulette tag, or just a single pick the first one to send the report. Okay. So as you can imagine, if there are some attackers that try to impersonate, I'm sorry, we'll talk about it later. Yeah. So what if someone just put a random email addresses so that you receive tons of reports? So for example, let's say I put my roulette tag intentionally to many different email addresses, victim addresses that do not actually want to receive the report, right? In that case, the reporter has to check if this, this specified email addresses in the roulette tag is actually willing to receive the report, okay? So if there is this kind of authentication mechanism, and theoretically the domain name specified in the roulette tag must be met, So the receiver who received the report has to explicitly say that, hey, I am willing to receive the report coming from this domain, which is called external destination verification. So in that case, so in these Virginia Tech Edu servers, it tries to forward all the reports to the marxian.com. Okay. In that case, if the marxian.com would like to allow to receive, would be happy to receive the reports for Virginia Tech Edu, then the receiver has to check this domain name first. VT.edu, the report in the DMARC and this domain name, right? If it can find the TXT record, it is a signal that, hey, I am the Marxian, but I'm also willing to receive the report on behalf of Virginia Tech.edu. Okay, so as you can tell, this is a two-way two-way verification methodology. So it is called external destination verification. Another one is BIMI, brand name indicator. So the concept is very simple. So these days, when you open your mobile mail client, sometimes you will see there is a logo on behalf of the sender, the first letter of the sender domain name. So this protocol lets the email client show the authenticated logo, instead of this showing the first character of the sender. Okay, so to support that, you have to also publish a TXT record that locates the logo image, XVG, sender vector image graphics, as well as the certificate. So if the certificate is valid, it is signed by legitimate CA, as we learned from the HTTPS class, then the email client will fetch the logo from this URL to show the authenticated logo, so that the user, without being without being afraid of phishing attempt, as soon as they can check the logo, then they can be sure that, oh, this email sender must be valid. Okay. But also, for example, I just did copy this SVG and get the certificate, downloaded the logo, CNN, and as you can tell, there is a certificate, and you can actually validate the certificate using this pen file. Okay. So let me show you an example. So let's say default beamy.com, right? And you will see the location of the logo. You're right, there is a logo. Oops. Oops, I'm sorry. Valid, right? There is a certificate which is valid. Yeah. But the thing is, the BME hosting a BME certificate is very expensive. So, for example, DigiCert promotes this BME certificate, but it costs you about $1,500 per year, which is really expensive. So another protocol I'd like to introduce is MTA-STS. I will cover this topic later, but let me try to keep it short because I'm going to cover it later again. So it tries to provide encryption, the receiver authentication, and also encryption of the email content. So they use a DNS to provide additional trust layer of the receiver email. So how it works is, you first look up the MTA-STS records, and after that, you go to the policy file. You're gonna using that domain name, you retrieve the policy file by fetching the HTTPS content, and you compare with the certificate. But let me tell you later. Okay. Right. There can be some other concerns as well. So for example, if this email is using a folder. So for example, let's say we are using a folder. So in case of Virginia Tech, I'm forwarding all the email to my Gmail personal account. In that case, mail from header, which is a index indicates White House sent the email, and the mail from is also from White House, and the recipient to is TJ, and the from domain name is actually whitehouse.gov. Then the folder just to forward the email to the Gmail. In that case, recipient to will be changed, and also mail from has to be changed to TJ at Virginia Tech Edu, because the sender email server is actually the folder Virginia Tech Edu. In that case, mail from will be different, right? Will be not matched with the from email address, which makes the SPF checksum or DK records can be, broken, right? So if you were interested in the past, please take a look at the ARC and other protocols to solve this limitation. But it's the advanced level, so let me skip it. So as you can imagine, this email secure protocol is really complex. So yeah. And another one is crypto libraries. As you can tell, authentication, integrity checking is all involved with the crypto libraries. So sometimes if some small open source based email clients, they develop their own their own crypto libraries to support all the cryptographic operation. In the case, it is very prone to make some errors. So it depends. There are lots of open source based SMTP solver software out there. So if you pick a wrong one, then it will cause some, it will make some problems, right? Because if that software using some less reliable crypto libraries, then it will make some problems. So please make sure to use a popular one. Okay. So I just skimmed through not all, but the major security email protocols used these days. So next class, I'm going to focus on this part because in this class, I mainly focus on this part, right? So next class, I'm going to talk about the how email sender can verify the receiver, and also how you can use the information to encrypt the email. All right. Thank you so much. Again, if you have any questions, please feel free to email me, tj@virginiatech.edu. Thank you so much, and see you next class. Bye.